In the previous video, I explained how to declare a variable, and I explored some of the possible identifiers and some illegal identifiers. I also briefly touched on the fact that every variable has to have a type, and that the value that a variable can take on is determined by that type, although all variables can be null. In this video, we're going to go a bit more into some of the types offered in Java. So I've written out the main primitive data types here. Actually, all of the primitive data types here. Now, a primitive data type is just a very fundamental data type. It's something you can't break down any further. So, of course, we have int, which we've already seen, and that's a positive or negative or zero integer. There's some redundancies in there. And it has a certain range, but essentially the main thing to remember is that it's 4 bytes of information. A short is 2 bytes, a long is 8 bytes, and a byte, surprisingly enough, is 1 byte. Now, most of the time when working with integers, you'll find yourself working with ints. It's somewhat rare that you'll find the need for a long. I mean, something has to be pretty big before you can't store it in 4 bytes. And I haven't seen many programs that actually use bytes, because unless you're working in something that's deliberately under 1 byte, you're going to find byte to be far too restrictive. So that is kind of the integer subgroup of primitives. Now we have floating point numbers, and there's 2 types of floating point numbers, float and double. One is 32-bit and the other is 64-bit. Now, both these kind of have unlimited range. And to kind of explain why that is, and why we have these 2 different ones, but they have unlimited range each, you need to understand some of the complexities of floating point numbers. And to be honest, the floating point system is quite complicated, so we're not going to be covering it at this point. I might not even be part of this series at any point, but essentially all you need to remember is that these 2 are different, and they do store different things, but they should have the same range. Whereas with ints and shorts, they do have very different ranges, as well as different kind of storages. And then we have a char, which is 16 bits, and it's any Unicode character. And this is important that Java uses Unicode, according to the Unicode convention. I know some languages kind of keep you in ASCII to make things simple, and Java is in Unicode. And then finally we have Boolean, and Boolean can take on either the value true, false, and of course null, because anything can be null. Now, what's important to note here, and this is worth really writing down, is that each of these types, and the reason we have to declare something and declare it with a type, is because Java is allocating memory. When you declare an int, Java's saying, okay, so this identifier signifies this point in memory, and it takes up this much space. You're basically allocating memory. You're allocating memory with each of these, and you're doing that in other languages when you're declaring a variable. But often you don't really see how much memory you're allocating, and the memory allocation is fluid. In Java, when I declare an int, I have set aside that space for that int, and even if I'm kind of actually only using enough space that could be stored in a byte, it's still stored in an int. Now, if I were to kind of delete this, it would get mopped up and deleted from the random access memory and garbage collection, and that's something for a whole nother day. That's not really worth discussing now. But it's very important to remember, when I declare a variable, even if I don't give it a value, I am giving it a type, and that tells it how much space to set aside and what the conventions for accessing that space are. Now, we're also going to talk about strings, even though they're not a primitive data types. And obviously, strings are made up of characters, and that's why we might call them non-primitive, because they can be broken down. Another important thing about strings, though, is that they are immutable. Once the storage has been set aside for a string, it's set aside, and you can append to it, but you can't actually take away from it. If you want to take away from a string, you have to basically delete and start over. You have to make a new string. So it's important. Strings are in many ways very simple, but in some ways quite complicated to work with, because you have to remember at all times that every time you're messing around with a string, you aren't subtracting for it, you are deleting it. And so that's strings. They're non-primitive and they are immutable, but they are quite a fundamental data type, so they're worth putting in here. Now, other data types will be discussed later. And objects and various data structures can also be kind of declared in a similar way, but we're not going to talk about that. For now, when you think variable, it's one of these things, and if it's one of these, it's primitive, and these are all kind of mutable. When we change an integer, unlike when we change a string, it's going into the memory where that integer is stored, and it's changing it. When you change a string, you're not changing it, you're deleting it and starting over. Anyway, that's been a brief coverage of a bit more about variables, data storage, and what we're doing when we're instantiating. With this knowledge, you should have a pretty good understanding now, between this video and last video, of how to create a variable in Java and what you're doing when you create a variable in Java. In our next video, we're going to be covering all of the different operators and some precedence orders, as well as potentially some typecasting. I know typecasting was meant to be in this video, but we're actually going to amend that schedule, because before you understand what it is to convert between data types, it's very important to understand why there even is a conversion between data types. When I convert between data types, I'm saying, I know I told you this was 4 bytes before, but actually I want you to get it 8 bytes, and that's what's called an upcast. But sometimes you'll be saying, okay, I know that I said this is 4 bytes, but actually we need it to be 2 bytes, and that's a downcast, and that can get complicated, right? Because you may have stored some things in those extra bytes, and you need to start considering that in your downcasting. But thank you for listening to this video, and I'm looking forward to the next one.